I saw this equation on YouTube, and I would like to solve it by using complex numbers. So I want to share with you my experience. Now, if x is a complex number, then x is equal to r cosine theta plus I sine theta, right? Good. Then 1 over x will be 1 over r times cosine theta minus I sine theta. Good. So this is my assumption. Then this equation could be written as x minus 4 over x to the power of 4 equal to 1. And this means 1 minus 4 times x, right? Yeah, to the 4th is equal to 1. So this means the 1 4 times, right? Minus 4 over r cosine theta plus 4 over r I sine theta. Yeah, 4th time. Correct. Now, see, this is 1, right? Therefore, the modulus of this complex number is equal to 1. So the modulus of this complex number is the real part square time plus this is complex imaginary part square equal to 1. So this means 1 minus 4 over r cosine theta square plus 16 over r square sine square theta is equal to 1. So which means 1 minus 8 r cosine theta plus 16 over r square cosine square theta plus 16 over r square sine square theta is equal to 1. Well, one cancel out, right? This becomes cosine square sine square is 1. Therefore, negative 8 over r cosine theta is equal to negative 16 over r square. Right? So from which that cosine theta is equal to 2 over r. Good. So we find x now. X is what? X is this, right? So x is equal to r times cosine, which is 2 over r, plus I sine theta. Okay, which is equal to 2, plus I r sine theta. Now, we still have r, right? It's not good. So we try to get rid of r by using triangles here. Cosine theta, this is theta. This is 2, this is br, right? That's cosine theta. So this side would be r squared minus 4. Okay. So sine theta is equal to So x is equal to 2 plus I r times sine theta. R times sine theta is equal to square root r square minus 4 over r, right? So this is equal to 2 plus I sine I square plus 4. Oh, well, it's still not good because they still have r square, right? But we know that this one is tangent 2 times this theta, right? So x is equal to, finally we found 2 plus I 2 tangent theta. Yeah, that's good. We get rid of r. Okay. That's right, because this length is 2 times tangent theta. So I have x now. Although I didn't solve for x yet, but I know what x looks like. X looks like this. The real part is 2. The imaginary part is 2 times tangent theta. Well, how to find theta? Well, we have to continue, right? Now, how to find theta? Let me show you a picture. This is 2. So my x is here. My x is on this vertical line, just a matter of theta. Okay, this is theta. X must be there. See, x is 2, the real part. Now, how to find theta? We're solving for x, right? So how do we find the x? We're looking for theta. Now then we have to go back to the equation, original equation, that equation. We have to use x minus 4. So x minus 4 will be equal to negative 2, right? Plus I 2 tangent theta. So this is my x minus 4. In the picture, the real part is minus 2. Okay, this is minus 2. So x minus 4 must be there. If they share same imaginary part, so if this is x, that will be x minus 4. If this is x, this will be minus x4. If this is x, x minus 4. If this is x, x minus 4, and so on. Now then, we try to find theta, right? Now, we go back here. This equation, if x is a complex number, x minus 4 is a complex number, then this complex number 4 times 4th power is equal to this complex number's 4th power. By using the Moore theorem, it says that this complex number's the argument 4 times is equal to this complex number's argument 4 times. Now, what is this argument? What is this complex argument? That is this angle, right? This angle. This is a pi minus theta. Minus. This is theta. Theta is argument of x. Pi minus theta is argument of x minus 4. They are equal after 4 times. That means this, okay, this argument, which is the argument of this complex number, 4 times will be equal to this argument, x argument, which is theta, 4 times. Here, the angle could be multiple of 2 pi, right? So the plus or minus 2n pi, right? So n is n is an integer. And from which we can find theta, right? Theta is equal to pi over 4 and 2 minus n, right? Yeah. Okay. So we found theta. Okay. Now how to determine n? Now we have a range for theta, right? Because x is on this vertical line, therefore theta must be between half pi and negative half pi, not inclusive, because x must be on the vertical line. Now then, n equal to 0, theta will be equal to half pi, right? Well, not good. Not good, because theta cannot be half pi. N equal to 1 is a quarter pi, right? Hey, that's good. Quarter pi is good. N equal to 2. N equal to 2 and theta is 0, right? Well, that's good. 0 is good. N equal to 3. N equal to 3 is a minus quarter pi, right? Yeah, that's good. Minus pi is good. N equal to 4. This is not good, right? This is negative half pi, which is not good. N equal to negative 1. Wow, 3 pi over 4 is more than half pi. It's not good. So we have only 3 angles satisfy our range of theta, right? So finally we have solutions. So x is equal to, x is this. X is 2 plus I 2 tangent theta, right? Therefore, x is equal to, when x equal to 0, is 2, right? See, that's good. When theta is a quarter pi is 1, right? So 2 plus 2i. When theta is a negative quarter pi is a 2 minus 2i. So these are 3 solutions. Yeah, very good. Now why 3, not 4? Because when you expand this bracket, the x4 and x4 could be cancelled out. So left over the cubic function, cubic equation. So you have only 3 roots. Now I have other videos to solve this equation. And to solve this equation, okay, also by using complex numbers, you can find and refer to my video. No, I think they are very interesting. Okay, this is a very nice question to practice solving equations by using complex numbers. Thank you for your watching.